Hi and Assalamualaikum. We are from Group 3. Our devices are called a PAS system, which means Portable Automated Smart Strike System. And next is our mentor, Dr. Hamzah bin Sakiran. We are a group of 5. Our leader is Tan Shin Lin. Our secretary is Chong Mei Yin. Our bursary is Noor Hida binti Omar. And me, alias Surah binti Mazlan, and Muhammad Aziz Iskandar bin Shah Iskandar is our members. And I will continue my presentation with the introduction. So, what is PAS? PAS is an gait analysis system to study the human motion as well as instrumentation to record body movement, body mechanics, and muscle activity. And it also to examine and treat persons who have locomotor system problems. And our PAS are made for the young adults who suffer from the sport injuries, such as ACL injuries. And our PAS are also used for the rehabilitation and diagnosis that can be performed by just staying at home. And to continue is our problem statement. First, our problem statement is anterior cruciate ligament, or known as ACL injury, patient needs to go through the physical therapy treatment daily from 3 to 6 months. Next, our patient who reside in the rural areas or who live far from the treatment center and do not have access to the transportation. And lastly, is because of the expensive price of the gait analysis device that already exists in the market. And lastly is our objective. First is to design a suitable automated gait analysis system for gait analysis diagnosis and rehabilitation. And second is to propose a system that can store and transfer data between the patient and the medical practitioner. And lastly is to develop a low-cost, user-friendly, and reliable home-based system for the gait analysis diagnosis and rehabilitations. And that's all.
Now, I will explain the details about our market survey and HLQ of our project. Our group has distributed a questionnaire and collected around 40x respondents who fall into two main categories, which is professionals, careers, and the general public patients. So most of the respondents are from patient and public people, and around 37% of our respondents is from professional careers. These are general questions that we ask in the questionnaire for the patient, and most of the symptoms that they respond is that they feel pain and swelling, while most of the causes is because their knee is hit directly that injured them, which got their ACL injury. So the question that we ask from our professional careers is about, and they respond around patient receive per month was around 5 patients, and the age group of the injury ACL, most of them are around 21 to 40 years old. And also we ask about the mortality rate, the doctors to the patient, and most of them check their and monitor their patient around 5 times per month. This is house of quality of our project. So based on the table, we get that most of the requirement, the highest rating is about the safety for the device, and reliability and interface were the second highest rating, and the third highest rating is portable and very easy to use to patient and doctors. And there's a less rating, which is affordable and simple design, also a small size and lightweight for our new device.
Good day, I'm Tan Shilin, the leader of IDP Group 3. Now I will present about the components used in designing the PAS system. The components used in designing the PAS system are Arduino Mega 2560 as the microcontroller, 9-volt alkaline battery as the power source, two types of sensor which are MPU 6050 and FSR 402, Wi-Fi module ESP8266, and Tinker.io. Arduino Mega is a tool for controlling electronics. It is able to read the input from the sensor and convert into output. It can be programmed using Arduino IDE software by writing, compiling, and uploading the code into the Arduino board. 9-volt alkaline battery provides electrical energy to the Arduino board. Its advantages include high energy density, long lifespan, and more safer. MPU 6050 is the sensor for motion processing device. It combines both 3-axis accelerometer and 3-axis gyroscope. It can be used to measure acceleration and angular velocity. FSR402 is a force-sensitive resistor which used to measure weight and force. It will vary its resistance depending on the amount of force applied. The higher the force applied, the lower the resistance. ESP8266 is a Wi-Fi module that allows the microcontroller access to a Wi-Fi network. It allows the transfer of data wirelessly from the microcontroller to the IoT platform. Tinker.io is a IoT platform that allows the building of interfaces for controlling and monitoring hardware projects through web or mobile app. It can store data in the data buckets and display the data in real time from the system or historically from the bucket using the dashboard created. That's all. Thank you.
Hi, my name is Nawaida binti Omar, and today I will explain about the product architecture of this device. First of all, the system consists of initial measurement unit sensor IMU that will measure acceleration and angular velocity, force sensor that measure force exerted on the feet by patient, power source will supply DC power for the device to operate, display system to display gait parameter, microcontroller which is Arduino to process the data from electronics component, Wi-Fi as data transmission module to transmit and store data from microcontroller to display system, shoe insole as the attachment to force sensors, belt to fix the shoe insole and the electronics component, and finally casing as enclosure for electronics component. Next, I will explain about the schematic diagram of the system. As for the schematic diagram of the system, as you can see, the input of the system consists of force sensor FSR402, 9V alkaline battery, and IMU sensor, which is MPU 6050. All of these input components will collect data of force exerted, acceleration, and angular velocity that we process and transmit through Wi-Fi module. The output of the system is the display of the gate data and storage of gate data in the driver via IoT application we use, which is Blink application. I will also explain about the mechanism of the system. One of the main mechanism of the system is the force sensing mechanism. The data measured from the sensor will be fed to motherboard, and the outcome of this mechanism is the amount of force exerted by the user while using this device. Another one important mechanism of the system is the acceleration and angular velocity sensing mechanism. The sensors are used to obtain the speed of patient's stride and the body coordination of the patient. The interaction between these two mechanisms is essential as there is purpose of this interaction between these two mechanisms. The acceleration and velocity sensing mechanism interact with force sensing mechanism at the same time. IoT operation will rely on both of the mechanisms to display and store the data measured. Both of these mechanisms may cause thermal dissipation as well as the motherboard and power supply. Hence, the electronics component are enclosed in the case to protect the user and shield the analysis devices. That's all from me. Thank you.
Good day, my name is Chong Mei. My matrix number is 181151573. Now I am going to present the design and the demonstration of our project. Okay, this is our design. The casing consists of Arduino, breadboard, MPU, and also the wires. And the belt is used to fix the casing on our shank. And the insole consists the force sensor and can put into our shoes. And next is how we use the product. Okay, first we put the insole into our shoes, then wear our shoes. Make sure the shoes is tight. And then we fix the casing with the belt on our shank. That's how we use it. Next, this is how we use our product. To show it clearly, we didn't use it in our shoes. Next, from the serial monitor, we can see that how the force is distributed when we are walking. This is how the serial monitor looks like when we are walking. And then this one is the data from the MPU to show the acceleration from XYZ and also the gyroscope from the XYZ.